Hi, why in 2024 do oscilloscope manufacturers still manufacture and sell and market two-channel oscilloscopes? It seems crazy, and you've no doubt heard me say in recent reviews, ever since like the four-channel Rigol 1054Z, for example, sort of like set the benchmark for four-channel low-cost oscilloscopes. It was like a total no-brainer that you'd buy a four-channel scope these days. So why do oscilloscope manufacturers still manufacture and sell two-channel scopes? Well, it's an interesting question which leads into some industry discussion on test engineering and education and various things, so stick with me. This little blab video was inspired by a post on the EV blog forum where everyone discusses all the latest test gear and everything else. It's the place to be. Linked in down below, as always. You can even join the Test Equipment Anonymous thread for those of you who are rather obsessed with test gear. So it seems an absolute no-brainer. If you're buying an oscilloscope for general purpose benchtop use, you'd go for four-channel, and that's obviously the case. I'm not going to argue that you should buy a two-channel oscilloscope for a general purpose lab scope. I think that's pretty crazy unless you absolutely have to save every last cent. And of course, that is one of the reasons why the oscilloscope manufacturers manufacture two-channel models, because, you can save a little bit of coin, but for a general purpose scope, you don't really want to do that. And even like higher end scopes like this Tech DSO 4000 series here, like for the 350 meg 4-channel version, you're talking $16,500 US, and for exactly the same one but available in only a physical 2-channel model, it's $13,000. So okay, you're saving like $3,000, a bit under $3,000, but like when you're talking about that sort of price point and typically budgets for that sort of price point, it's neither here nor there. If you're buying a general purpose lab scope, you go for the 4-channel. Because if you're an engineer who's got a lab budget for like a general purpose oscilloscope, you're going to spring the extra couple of grand in there. No worries. But all the manufacturers do it, of course. Here's Tektronix's new 3 series available in 2 and 4 channels. It's probably not a huge price difference between it. Rigol here, for example, their lower end ones available in 2 and 4 channels here. And well, if you can't see the price, yeah, like there's hardly any different. Couple $100, yeah, you go for the 4-channel. No brainer. Rohde & Schwarz, their RTM 3000 here, available in 2 and 4 channel models. And hardly any difference in price there, really, at that sort of price point. So you might think price point is the only reason that the manufacturers do this. And whilst that's true, absolutely true, you've got to remember that there are actually many different markets out there different to the general purpose benchtop oscilloscope market. In fact, that might not even be the main market for oscilloscopes. You just buy, I've got a lab, I want a benchtop oscilloscope. Please, manufacturers, leave it in the comments down below or over on the EV blog forum thread, because the manufacturers do join in the EV blog forum. Fantastic, by the way. Please chime in. They're probably not going to give us sales numbers, but you might be surprised to learn that there are many different markets out there. A huge one, of course, is education market. And companies like Keysight and Tektronix, for example, they market specific models, including all sorts of training material for the educational markets. So if you want to kit out a university, lab, engineering school, tech school, or whatever it is at one of their labs, then you're going to need many of these oscilloscopes, right? Each student's going to need, or each pair of students or whatever, each bench is going to need their own oscilloscope, and they can sell these in very high volumes, and they also sell them at quite decent discounts as well. But specific models for education, for example, you might only need a specific 2-channel model because you've only got that lab set up to do very specific experiments. They're not general purpose labs. They're just set up specifically physical lab experiments already in mind and set up. And they might only need a typical 2-channel oscilloscope for that. So their requirement when buying an oscilloscope is we want a 2-channel oscilloscope. I don't care that you're selling a 4-channel one. I only want 2 channels because then it doesn't confuse the students. They dick around with the leads and whatever whatever, or they select the wrong channels and everything just comes a gutter, right? No, you want to keep it simplified. You want only a 2-channel scope. So a lot of the manufacturers, especially in the lower end and even the mid-tier models, they're going to offer these 2-channel versions. So even if a company offered a 4-channel oscilloscope for the same price as a 2-channel oscilloscope, a lot of the educational institutions, they go, no, we don't want the 4-channel. We deliberately don't want it. Please only give us a 2-channel oscilloscope because we don't want the kids mucking around with them. And that just wastes our time. But the other big one I wanted to talk about is test engineering. And this is what I spent probably 15 years of my career doing, is test engineering. Basically designing and building one-off or low-run test gear for various production facilities and various manufacturing type stuff. And test and production engineering is a massive market it's so big that manufacturers, I'll show you in a minute, manufacture specific oscilloscopes for this actual market. Now, a good example of a test engineering rack, for example, I'll link in this Linus Tech Tips video here. This is a power supply testing rack, huge 19-inch rack. Okay, it's designed to go on in this particular case, to test power supplies. So they sit it in the corner there and they can test PC power supplies with this thing. But you'll notice that a lot of these test racks, they will use off-the-shelf test gear, and they're supposed to have an oscilloscope that actually sits up the top here in a rack mount, and which they don't actually have that at the moment, but they're off-the-shelf multimeters, off-the-shelf power analyzers, off-the-shelf power supplies here, and down on the bottom side here's an off-the-shelf AC power source, for example, and another bit of off-the-shelf gear here, and then down here you might have a whole bunch of like analog cards or something like that. Like National Instruments is like the biggest player in that market, and they'll sell you really expensive all these boards that plug in, so off-the-shelf solutions. And then the production test engineer might have developed like a custom interface box, for example. Like down here it's got like the custom AC outlet, and it's got various little indicator displays and like custom indicator displays and stuff like that. And you can actually hire companies that will actually design these test racks for you, and a lot of the manufacturers will actually do this as well. If you're a big enough customer and you're willing to pony up the money, then you can do this. But it's very common to use off-the-shelf test gear for this sort of thing, including oscilloscopes. And all the big manufacturers will offer you rack mount kits for your oscilloscopes here. Look at these, right? Really cool. So like Tektronix offer a rack mount kit for every single one of their oscilloscopes. There's the rack mount option, right? Every single oscilloscope ever made, they offer a rack mount kit for it. So they're really cool, and you just mount the oscilloscope in a 19-inch rack. Now, if you're a test engineer and you're developing a test solution, of course you might only have a set amount of room in your 19-inch test rack, for example, and oscilloscopes are usually like pretty high form factor, especially the modern ones these days with their big ass screens and everything, right? That takes up a lot of rack units in your rack space like that. But hey, as a test engineer, I would usually prefer to spec in an actual oscilloscope with all the controls, like a real benchtop oscilloscope, and put it in the 19-inch rack instead of a specific designed rack mount oscilloscope, because, well, as the test engineer, I just like I like my knobs and everything. And at the development and troubleshooting stage, it's nice to be able to stand there at the rack and just twiddle with things and just fix stuff on the spot. So from a development and troubleshooting point of view, it's often better to have a real dedicated oscilloscope there. The only downside to that, of course, is that the production testers, they can fiddle with it as well, but you can do software lockouts for the front panel. So you can program that into your test script. It'll actually lock out the front panel. But of course, you as the test engineer that comes along, you got to troubleshoot something, you can override that with your super secret squirrel password, and then you can fiddle around with the oscilloscope. So that's really handy. But companies do actually offer headless oscilloscopes, they're called, or low profile oscilloscopes. All the major manufacturers have these, and they will have them in these rack mount versions. So here's the the new 5 Series Tektronix available in a rack mount version. It's exactly the same. It just has no interface. For example, Rohde & Schwarz, the new MX-05, kicks ass, right? It's got a little e-ink, custom e-ink display on there, but it's an 8-channel low profile rack mount oscilloscope. So it only takes up like 2 rack units. And Keysight have this older one here. It's only 1 rack unit high. Beauty if you really are constrained there. And Teledyne LaCroix here, right? They've got a 2 rack unit. Like there's another 8-channel jobby. Rigol, right? Some of the more up and coming ones, not the old school top tier ones, they've got these rack mount units. Okay, Siglent have these new rack mount units as well. So all of the major players, half a dozen of them, do these rack mount oscilloscopes. And this is actually a big market that you as typical hobbyist or engineer with your little bench there, and you want your benchtop oscilloscope, and you haven't been involved in test or production engineering before, you may not be aware that these companies sell a lot of these. So if the likes of Siglent and Rigol, who are known for their lower cost sort of oscilloscopes, if they're getting into this sort of market, there's big volume there. And their customers have been asking for it. If you're Joe Blogg's engineer and you've got your Siglent or your Rigol benchtop oscilloscope and you really like it and you like the low cost and everything else, then if you happen, you might sort of find it very common as just a regular engineer to find yourself doing some test engineering or production engineering design. It's very easy to get caught up in that sort of thing, especially, all right, you're it. Right, design is this test jig. You're an engineer. Go and do it. Go on. We don't have the budget to hire a dedicated test engineer for it. You're it. So, if you like your Rigols or your Siglents or whatever brand you happen to be using, you go, oh, right. Do they have a rack mount version? Yes, they do. Now, engineers by their very nature, they're inherently frugal. So even if it's not their job, they're going to want to save the money. For example, you've got like a set budget, or you want to sort of like minimize the budget for a test system that you've got to develop, for example. And if you can save a couple of grand and you only need 2 channels on that test rack because your script is only, got 2 input signals, and you'll never need 4 because typically you design a production or test system not for expansion. You actually design it for a specific one-off task, and that's it. So you only need the two channels. So yeah, you're going to save you 2 or 3 grand or whatever by buying the 2-channel version. But hey, if you're a test engineer and you've got that open-ended budget and you don't necessarily think that it's going to be a problem with the production testers, that they're going to fiddle around with the 4 channels so you can just mask it out or do whatever, then you might spring for the extra 4-channel version, and they're going to dismantle that rack at the end of the production contract. So, well, you might be able to score that scope for your own bench. Huh? So yeah, there's pros and cons to saving money on production test systems like that, but just be aware that, yeah, a 2-channel might be a very big requirement, because 2 channels covers a ton of test stuff. But of course, these multi-channel ones here, of course, these all typically have like 4 or 8 channels. You won't get these, typically won't. Well, no, Keysight do make a little 2-channel jobby. Keysight and other manufacturers do actually manufacture, for example, these PXI rack units, and yeah, you might see that, you might get like a PXI rack like this, and you might actually plug them in like that instead of getting the one big 19-inch unit. But yeah, the advantage with all these rack mount ones is that you can typically like tie them together so that you can get massive, like 32, 64, 128 channels, all synchronous across, in terms of sampling and trigger and everything else. And that can be very useful for all sorts of production and research. And, if you're at the CERN Super Collider and you've got some massive, your massive parallel data that you're sampling and stuff like that, and you're sampling it real high, they might think, oh, why do I need like 128 channels of, 2 gigahertz bandwidth or something? There are research reasons for that, and which you may not know about because you're just working at your bench with your little benchtop oscilloscope. But there's huge markets out there for this sort of stuff, and you usually pay a bit of a premium coin for these, by the way. So your average engineer is not going to get one of of these typically for their bench, because you want the, the nice touchy-feely user interface with all your knobbies. And it can come down to either development time or, budget, whether or not you go, oh, okay, I need 4 of these things at 30 grand a pop, or whether or not you just get a regular 2-channel scope and then design your own little multiplexes, because often in these development systems, you don't need the full front end range, for example. So you're paying for, that entire front end from the 500 microvolts per division up to the 10 volts per division. You generally don't need that. You might only need like 0 to 10 volt input, for example. You just need that single attenuation input, and you might roll your own attenuators on the front end, and you might roll your own amplifiers, or once again, use a custom off-the-shelf amp, rack mount amp or attenuator or whatever. And yeah, you just don't need to pay for all that capability. But yes, sometimes you go, I don't have the development time to do anything custom, so you just say to the boss, oh yeah, we really need this. Trust me, we really need this, even though you don't need the front end at all, and you're paying for it. But hey, R&D development time actually costs real money and real resources, often more than what you'll pay for like complete overkill. Okay, you just need a fixed 0 to 10 volt input here, but you're going to use this big front end oscilloscope anyway. But it doesn't matter as long as it gets the job done for the budget that you've got. And companies like National Instruments, for example, will sell you all these PXI chassis, even nice little benchtop units like these. As a test engineer, I've developed lots of like custom test stations where they don't have big 19-inch racks. You will have the production worker just sitting at just a regular bench, and you might have little, physical test station depending on the device that you're actually going to put right next to it. And then you just might, you don't dick around with 19-inch racks and stuff like that. You just basically sit a bunch of benchtop instruments on there, but you don't necessarily want an oscilloscope, because once again, you don't want the production tester to actually start dicking around with the controls or everything that. You want everything scripted, but you don't necessarily want to go to all the complexity and bulk and everything else of a big like 19-inch rack. And you can just get like huge multi-channel versions like this, and they're all networked and they got all sorts of interfaces. And if you have to ask the price, you can't afford it. And there's other companies that'll do similar sort of modular solutions as well. So there you go. I went off on a little bit of a tangent there, talking about test engineering and stuff, but this is one of the requirements where you might definitely want one of those 2-channel oscilloscopes. And if you haven't worked in that sort of aspect of the industry before, or you're just a hobbyist or whatever, you might not be aware of the big markets out there, education and test and production and engineering and research and other applications where these companies, they still need to sell these specific 2-channel oscilloscopes. So as a little aside here, back to test engineering, I said that they typically would use off-the-shelf equipment like this. Why? Because, well, you're tasked with developing this test kit jig. You don't want to dick around developing anything custom unless you absolutely have to. And you've typically got, space in your 19-inch rack. You've physically got a lot of space to work with, usually in these sorts of applications. So you're going to use all off-the-shelf solutions. And look, in this particular case, they've got 9 different power supplies, and maybe they're paralleled up, or they switch them in different ways or something like that. And you might have to develop a custom switching box, or you might use, someone like National Instruments to do a system like that. And also another thing is, and how do you decide whether or not you just want to buy a standard oscilloscope plus a rack kit, even though you might need 32 channels or something like that, or whether or not, you want to buy something, a solution like this, or one of these other modular solutions here which you can tie together. How do you decide? Well, that might come down to your budget, for example, because, well, a 2-channel oscilloscope, for example, is going to be a lot cheaper than one of these big jobbies like this, right? One of these multi-channel things, right? $30,000 for this 8-channel oscilloscope. Let's say you needed 16 channels or something like that. You'd have to buy 2 of these, and you'd have to network them together and synchronize them and all that sort of jazz. And well, that could be very expensive. That could blow your budget, because you have to spend your budget somewhere else on some other gear in the test system, for example. So you might decide, hey, I'm just going to use a 2-channel oscilloscope, and then I might have a multiplexer card. So you might go to someone like National Instruments, and you might get one of their analog multiplexers, and you might do a sort of a cheaper solution that way. But generally, If you've got a big budget or an open-ended budget, you're going to go, oh, I don't want to dick around with sort of like, a separate National Instruments, analog mux or something like that. Don't want to dick around with that and then trying to integrate that and with the software for the oscilloscope. No, I just want a one dedicated interface. So bugger it, I'm just going to buy 2 of these or 5 of these or 10 of these. And as I said, like the only interface that you might need is some sort of custom interface for whatever product you're specifically testing. You might have a few, generic indicators or measurement or panel meters. It's always good to put panel meters in there so you can just put in your production test procedure that, if this panel meter here reads within this range, then it's okay. Or you might have, built in a simple window detector circuit to measure voltages that they're in range, or something like that, rather than have the production tester like read an oscilloscope, which is like really complex thing to train somebody to do, and they can come a gutser. And yeah, you want to simplify it as much as possible. You want to script the whole thing. But at what point do you, as a test or production engineer, decide that you're going to go for a completely custom solution instead of using off-the-shelf gear? Well, it's usually not budget, because it takes you a lot longer and more effort to actually, in terms of labor hours, to develop a fully custom electronics solution for something instead of just buying off-the-shelf gear and away you go, write a couple of scripts and Bob's your uncle, and just design a simple like little hardware interface for your product. How do you decide? It'll often come down to form factor. Can you actually fit all this commercial off-the-shelf gear into the form factor that you want? So let's go to the bench now, and I'll show you a real example I've got from my production test engineering days. And this is a design where it was basically a slimmed down, tiny, briefcase. It literally went in a briefcase so that you could take it on the back deck of a ship, for example. And it was basically a slimmed down, miniaturized version of an existing 19-inch production test rack. But because of the physical requirements, I had to design everything from scratch. So here it is. It's one of the few relics that I have from my previous test engineering days. It's the AFT, or Automated Functional Tester, I called it. And this was designed to go at the tail end, as it says, plug in the end of a seismic streamer here. And there's the product interface for that. And we had different products with different, some of them had like fiber optic interfaces and other stuff. But this one just had all custom pins. By the way, a connector like that, a custom, that'd be $500 a connector. Thank you very much. And it's just got a serial interface on the end and a mode off on like this, and an indicator LED which is vanished now. So let's see if we can take this out. And there you go. There's the internal wiring for that. And well, I did have a rail in there. But anyway, you might have seen this before, because this, it has been in a previous video. I've explained and looked at this. I did a whiteboard explanation of how this works back in my old Garage Lab days, so I'll link in that video. So there you go. We're talking 2002 here that I developed this. It uses the Rabbit 2000 processor. Hands up, leave it in the comments if you've used a Rabbit 2000 processor. The reason I used the Rabbit at the time is that it had a really easy to use real-time operating system. It was built into the compiler, basically, the real-time operating system, and it had like 4 or 8 serial ports built in, which is what I needed as well. And I've got a whole bunch of relay drivers here, and this board here is a complete LCR meter, and I've explained how to design your own LCR meter in the previous video that I'll link in. As grainy as it is, I won't go over it again. That board off there, we've got a relay switching matrix on under here with read relays on there like that. And this was, so it's a big switch-in test matrix, means that you could basically measure any combination of any of the pairs on here, which contained hydrophones and other things like induction coils and transmission lines. You could actually measure those. So this is actually just the tail end module. There's also a module that went on the head end, which did some more stuff, if memory serves me correctly. It was a long time ago in a galaxy far, far away. So I'm a bit rusty on that. There's some Pickering reed relays, and I've actually done a video on some of the limitations of putting relays like this all in parallel. I'll link in that video as well, because this measured insulation resistance as well, which was one of the requirements, not only LCR, but transmission line and insulation measurements. And so this basically replaced, as I said, a 19-inch rack, this plus the head unit, and then it used a little PC104 embedded processor. I'll link in that video as well. I might have some original boards there. PC104 industrial computer at the head end. And basically all of these, we basically had two of these modules, and they fit, plus the main controller and interface, they all fitted into a briefcase. So you could physically take it on a boat in the middle of the North Atlantic, and you could actually deploy this on the back end of a seismic survey vessel. So that's what this is for. But basically, yeah, this actually replaced a 19-inch rack. Sorry, I don't have any photos of it, that actually contained a HP 4339 insulation resistance tester. Very expensive, high-end bit of kit. Even the test cables for that cost about $2,000 each, if I remember correctly. Just crazy stuff, because they were triaxial and they were, you know, Agilent at the time, you know, wank, really expensive stuff. And also a PM6304 LCR meter, old Fluke Philips jobby. A very nice LCR meter, by the way, if you can pick up one of those secondhand on eBay. And yeah, basically, this was a custom solution designed to replace those, because we couldn't have a 19-inch rack. You couldn't carry a 19-inch rack on the plane with you, and then, you know, on the helicopter, which flies out to the boat, to actually go in and troubleshoot these cables on the back end of a boat. So this is what this totally custom solution was developed for. And yeah, I didn't want to have to design my own LCR meter, as fun as it was. Didn't have to want to design my own transmission line tester and relay switching matrix and everything else. But, you know, you have to do what you have to do to meet specific requirements. So the transmission line tester was actually on the back here. There you go. So that's the transmission line module there. Did some switching, and then it just had an adjustable DDS generator and a receiver and stuff, and you can measure, you could sweep transmission line parameters in the software. Oh, genuine mod, a couple of mod wires on the bottom there. So not sure if this was the final version or not, but this is an example of something that wasn't just a one-off. We had a requirement for like a dozen or 2 dozen of these things for, you know, various field engineers to go out there and use, you know, so we're not in the thousands or hundreds, but, you know, a couple of dozen. So you don't really have to like try and, you know, save cost on something like this, because, you know, the price is what it is. Although we did sell this to a customer, we're selling it to the one and only customer we had, which is buying, you know, tens of millions of dollars, hundreds of millions of dollars worth of product from us. So, you know, it didn't really care what these things cost in the end. So you didn't have to cost optimize the design at all. And each one you could easily like hand assemble if you have to, and hand test, so you didn't have to like do production test panels to, you know, automate these boards, because you're not making them in volume. You're only making a dozen or two, so it's just, yeah, it's easy to just manually test these things, and even hand build them if you had to. No worries. There you go. I hope you found that video interesting, and if you did, please give it a big thumbs up, and as always, discuss down below. And if you've worked in the test engineering, production engineering, research, educational things, leave your thoughts and comments there as well. And as I said, the EEV blog forum, and don't forget to check out the store, the eevblog.store. That's the domain name, and you can pick up some of my meters. Catch you next time.